Welcome to Populations and Ecosystems Investigation 6, Population Size. Students will explore some of the ecosystem factors that limit the size of a population. Investigation 6, Population Size, has three parts. Part 1, Reproductive Potential. Students will use a model to better understand population growth. They will calculate theoretical growth of a milkweed bug population with no limits. Parts 2 and Part 3, Part 2, algae and brine shrimp populations, and Part 3, population dynamics, students will relate abiotic and biotic factors to the growth or decline of populations. As always, I have included the Behind the Tab investigation matrix for your review. Investigation 6, Part 1, Reproductive Potential, Session 1. After observing their milkweed bug populations, students calculate the potential population growth at 2-month intervals for a year. Engage students in the activity by having them define the word population. Discuss milkweed bug populations using the scripted questions that's outlined in the teacher's guide. Ask students if they have a population of milkweed bugs in their bag. How big is the population? Will the population continue to grow? And how big will the population be in a month or in a year? Introduce reproductive potential. Tell students that every population has the potential to increase in size. If you have the proper information at hand, you can calculate the potential for population growth for any organism. The theoretical unlimited growth of a population over time. Introduce the student sheet using Transparency 13 to display and review the student sheet. Tell students that entomologists have discovered information about the bugs that will help them calculate the population growth after 2 months or a year, if nothing limits population growth. Have students begin working on the student sheet. Provide calculators if you have them available. Guide the procedure, again with some of the scripted questions that are listed in the teacher's guide. Discuss the results using Transparency 14, Unlimited Milkweed Bug Population, to guide students through the calculations to ensure that everyone understands the sequence. Summarize the process. Review the important facts that affect the population calculation and put the population in context by comparing the population size to something tangible that students can relate to. For instance, telling them that the number of milkweed bugs in their year's calculation could circle Earth 8 times if they stood in line nose to tail, or they could cover about 8 football fields if they all crowded together but didn't crawl on top of one another. Discuss the implications. Tell students that clearly the population of milkweed bugs does not increase in the real world at the rate we calculated. What prevents the population of milkweed bugs from covering the planet? Give students about 3 minutes to talk in their groups to come up with the reasons why the population is limited in the real world. Introduce limiting factors. Tell students that populations are subjected to limiting factors in the natural world. A limiting factor is any biotic or abiotic factor that acts in some way to limit the number of individuals that survive and reproduce in a population. Ask students what are some possible limiting factors that might prevent the growth of milkweed bugs in nature. After observing the milkweed bug population, students calculate the potential growth at 2-month intervals for a year. Review the unlimited population growth. Ask students what would happen if one variable changed. What would happen if the females laid 150 eggs? You're going to use the computer simulation to calculate the reproductive potential of milkweed bug populations with different characteristics than the one we investigated. See the link below, run the simulations. Students will see that their results were similar to the calculations. Now you're going to change from the milkweed bugs unlimited to the milkweed bugs limited simulation. All variables are the same except space, which is limited to 800 cubic centimeters. Run the simulation and discuss the results. Guide the program as outlined in the teacher's guide. Once students have completed that, introduce the student sheet. Read the 4 questions on the sheet, Students should continue to work with the Milkweed Bugs Limited simulation to answer the questions. Discuss the results from the investigation. At this point, I introduce variables to students because we have seen the word variables or heard the word variables a number of times in the limited and unlimited population growth simulations. And it's important for students to know what a variable is and the types of variables they will be using when conducting investigations. Tell students that a variable is any factor that can be controlled, changed, or measured in an experiment. Discuss the different types of variables, and have students record them with their definitions in the glossary of their notebooks. Students will analyze the results of a laboratory study to determine the limiting factors of 3 abiotic factors. Read the milkweed bug hatching investigation with students. Have them identify the different variables as they come across them, independent, dependent, and controlled. Tell them that anytime they communicate their findings from an investigation, they should always list the variables that were used. Next, analyze the hatching investigation. Have students summarize the results of the investigation and record their conclusion on the results and summary sheet. Part 2, Algae and Brine Shrimp Populations. Students will relate abiotic factors to the growth or decline of populations. Recall Mono Lake. Briefly review the community and the key organisms that act as producers, consumers, and secondary consumers. You can read the script that is written in this section to engage students. Introduce the algae and brine shrimp experiments. Read through the experimental design and setup with the students, making sure they understand the major factors they should be observing. Analyze the experiments. Some students may benefit from some suggestive questions. Guide the discussion using the questions that are listed in the teacher's guide. Discuss the analyses, restate the definition of limiting factor, have groups share their conclusions. Next, assign the reading limiting factors. Students should read, annotate, and answer text-dependent questions. Use the science literacy page, Brief Guide to Creating Text-Dependent Questions. See the link below to assist you in creating your own text-dependent questions. Assess students' progress using the student sheet. Investigation 6, Part 3, Population Dynamics. Students learn that population fluctuation is not necessarily an indication that an ecosystem is unhealthy or weak. Introduce the Mono Lake data. Project Transparency 15. Have students study it for a minute and make a prediction to the following question. Based on what you know about the populations of planktonic algae and brine shrimp and the light and temperature conditions at Mono Lake, how big do you think the populations of those two organisms will be over the course of a year? Compare predictions to data. Allow students time to study the graphs and ask a few guided questions. Discuss the biotic factors. As always, there are scripted questions in the teacher's guide that you can use for these discussions. Allow students time to give examples. Propose other biotic relationships. Analyze the graphs. Have students write responses to questions on student sheet. Analysis of Mono Lake data, using information in the graphs to support their ideas. Have students record notes for the following discussion points. From this point on throughout the book, it is mostly teacher lecture. Have students record notes as you review information. Revisit abiotic and biotic factors. Summarize the ecosystem. Introduce the interdependence. Discuss ecosystems and balance. Assign Mono Lake in the spotlight as reading. Remind students that, as always, any articles they are given, they should annotate. Remember to create a few text-dependent questions. Discuss the gull issue related in the reading. Summarize the effect of abiotic factors. Discuss their influence on ecosystems. Conclude the investigation by giving them mid-summative exam number 6.